This is Accelerate Your Earthwork Subgrade Volume Calculations and Civil 3D. My name is Brian Tanner. I'm a Senior Civil Technical Specialist with ATG. Today's date, April 13th, 2021, is our live viewing of this webinar. But for anybody who's not joining us today or would like to share this with coworkers or colleagues after the fact, we typically have this webinar and all of our webinars available within a few days on our YouTube page. So feel free to keep an eye on that. Make sure you're a part of our email list and follow us on social media so that you can see when that link becomes available and that video becomes available on YouTube to share with your professional counterparts. All right, again, Brian Tanner, Senior Civil Technical Specialist with ATG. I'm a Civil 3D certified professional and Autodesk certified instructor. I have 15 years of in-industry practical project experience, ranging from DOT work, commercial and institutional site development, municipal road and utility work, public parks and recreational pathways, a little bit of experience with hydroelectric dams and levees, kind of a unique area that I've enjoyed working within, as well as our local county highway and drainage type projects. So the breadth of experience that I've had over those 15 years is all using the Autodesk AEC collection and the tools within that collection to complete those designs and to deliver those contractual documents and blueprints. So what I'm going to show you today, what I work within in Civil 3D and the surrounding supporting tools of the AEC collection are all practical and all apply directly to these types of projects. I'm one of 12 people from our civil services team here at ATG with similar levels of experience and expertise. Because it's not just the number of jobs that we've worked on, it's the level and quality of the work that we've produced over time that we've become a trusted resource for our industry partners, for our clients, and for our potential future clients working on training, implementation, serving as a CAD management role for your organization, as well as producing plans and part of our production team and developing models and helping you get projects out the door. Today, we're going to specifically talk about 3D subgrade surfaces within our civil product. And we have to cover just very briefly. We're going to spend very minimal time inside of PowerPoint today. Most of the work that we're going to do is actually inside of Civil 3D. And we're going to break down some of the tools that we have available out of the box, as well as a workflow that we could potentially take advantage of if we have some other tools available to us. But 90% of what we're going to cover today applies to everybody, regardless of what version of Civil 3D you're using, with some, exceptions. I'm gonna kind of make a boilerplate statement that if you're on anything from 2017 and later, we're capturing anything that you could potentially work on in Civil 3D. There's nothing special about the latest and greatest version of Civil 3D that you would not be able to take advantage of these tools if you don't have that subscription or if you don't have the latest version of the software available. But Civil 3D surfaces is the basis of what we're going to be working on today. There's several out-of-the-box methods for creating a surface. Existing surfaces themselves, we've got survey data, LiDAR, GIS contours, or DEM. This is just the type of data that we build our existing surfaces off of. It's critical that we understand that those surfaces are traditionally built off of a triangulated irregular network, a tin surface, and the quality of that data improves the quality of our output whenever we develop subgrade surfaces, and not just the subgrade surfaces for our proposed information, but the comparison of the existing versus our design surfaces for the quality of earthwork calculations that we're going to produce as well. And we can also produce proposed surfaces from manual feature lines as break lines, grading groups, and corridor data. I guess it's important to note that grading groups are really just a framework of feature lines. And really our corridor data is a framework of feature lines linearly, more or less parallel to our alignment and profile. But we could also build our corridor data off of our links crossing our assembly frequency within the corridor as well. So although we have feature lines built out as a framework for just manual feature lines, grading groups, and corridors, sometimes our corridors are, the surfaces developed from the corridors rather, are built off of our link data from our assemblies in those corridor models. Subgrade surfaces really are something that we can calculate rather quickly as part of our corridor surface, or rather our corridor model. We can develop a datum surface quickly off of those bottom links of a corridor to get a subgrade value along linear projects. But we don't always work on linear projects. Many times we work on area projects, site projects, expansion projects. And we have to consider soil stripping, limestone treatment, stabilization, hard surface and sub-base depths for our engineered materials, and how deep that cuts into our existing surface, or how much we have to build our existing surface up, taking into account that we have topsoil that we want to preserve and reuse on the site as well. So we've got stripping, stabilization, we've got engineered grades and things of that nature. And we also have our structures. We have, building and bridge foundation depths. Technically speaking, we have the depths and the volumes of our storm and sanitary structures, though it's rare that we really include those spot values as part of our overall earthwork calculation for, let's say, a roadway project and things of that nature. Kudos to those who take it to that level of detail. And we certainly have workflows that we could accommodate that, just not something that we're going to cover specifically today. The varying material depths for all of these different area types, soft surface, hard surface structures, basic soil stripping and stabilization. In order to get those varying subgrade depths, it takes a process of pasting our design surface and bounding it into multiple Civil 3D surfaces at lowered to the subgrade depths of those materials, potentially pasting those back into a composite subgrade earthwork surface. It's another step further that you could take. Ultimately, we do need to know what the overall earthwork on a project site is. So pasting a subgrade depth back into a composite earthwork surface is just as valuable as having a corridor and a finished grade for a site design and merging those into a composite proposed finished grade surface. So once we've got our subgrade surfaces through that method, that out of the box method, we would develop a volume surface to compare and calculate our existing conditions versus our subgrade surface. That's going to get us our earthwork values. And because we don't have a corridor that and subsequent sample line groups, we also need to calculate maybe our material itself. What's the quantity of pavement? Yes, if we know our depth and we know our area, we can calculate our pavement values by hand. Don't get me wrong, or we can use an Excel spreadsheet for simple things like that. But if we're already developing our subgrade surfaces inside of Civil 3D, if we're already updating our design inside the software so that we can not just calculate, but also display our overall design, then why don't we just use the software in our benefit to also provide those calculations for what our material volumes are as well. So let's jump into the software. I told you we're going to have kind of a minimal amount of time inside of PowerPoint, and we're just about done with it already today. So bear with me. I'm going to jump into, leave the correct drawing. And I've got basically two identical example drawings that we're going to work off of today. A little bit of Food Network magic jumping between two versions of the same drawing, one that will use a traditional method for, and one that will use a new method or a third-party tool for expediting this process. Bear with me for just a second. It looks like Civil 3D is catching up with me as my tool space is blanked out. Sometimes clicking out and clicking back in does the job. I know we all have a tendency to want to hit escape a whole bunch of times, but really that doesn't do anything for us inside the software. Clicking into a different application and back into Civil 3D, as de minimis of a tip as that might be the one thing that allows us to work just a little bit more quickly and allow Civil 3D to catch back up. Okay, so in the software, a little bit of Food Network magic. I've got a demo 1 drawing and a demo 2 drawing. If I had done a zoom extents on both of these, you'd see that they're identical drawings, identical data, identical surfaces and things of that nature inside the file as well. And I may have just slowed myself down again by jumping between those drawings. There we go. But they're identical, same existing surface, same proposed surface. And that's what we're going to be working off of today is we have a finished grade that represents our proposed design. The grading groups are already developed in this drawing. It's presumed that whenever you're ready to develop your subgrade depths, you already have a design surface. Even if it's not a finished design surface, you have something to base it off of. So we can create our subgrade surfaces, whether through a traditional out-of-the-box way or an advanced third-party workflow way at any point in time in your design process, just as long as we have a proposed surface to start to work off of. The only other setup that's really in this drawing, aside from having a proposed grading surface and an existing grade, and obviously those were built off of the grading groups, as I mentioned before, is we have some boundary lines that were developed in this file that represent the limits of different depths of grading. So in this case, we have a green line that represents the outer limits of our just soil stripping and stabilization surface depth. We have an industrial drive or a depth of pavement with sub-base treatment for where our driveway will be for heavy traffic, as well as a parking lot for more of your passenger vehicle pavement depths, and again, base and sub-base treatment for our engineered subgrade depths. That's the only thing that's special in this drawing. Yes, those polylines are set up onto a specific layer. Again, labeling things and naming things appropriately inside of Civil 3D only helps to inform us as a user, and anybody else who steps into a project later on allows them to pick up the reins and understand why things were created the way they were. So that's the only level of organization to this drawing that's special. And again, it's identical between the two drawings that I have open. So our first workflow that I'll talk about today is that traditional out-of-the-box workflow. If you happen to tune in last week, Thursday, or if you check out our YouTube page, I want to give a shout out to Kyle Groves from our ATG team. He actually covered a very similar process last week using a near zero methodology for a dropped set of surface information to automate some of this traditional workflow process. I encourage you to go check that out. His video was just a little bit over an hour once you include all the Q&A, but there are some really great nuggets of valuable information from his webinar that will overlap a little bit with mine today too. But we're gonna take a slightly different approach to the traditional method of creating subgrade surfaces. So we do have, as I mentioned before, a proposed finished grade surface. If I select that in the drawing, we've got our pond, we've got our finished grade outside of the building, and we've got our parking lot and drive set of contours that you can see representing that information. For me and my workflow for the traditional out-of-the-box method, I want to create several subgrade surfaces that represent each material type. That may include multiple duplicate versions of this surface that are lowered to the subgrade depth. So let's talk about that workflow. I'm going to first, you see that I use a folder method of organizing my surfaces. It may not make a whole lot of sense since I only have one existing surface and one finished grade surface in this drawing and no composites up to this point. But as I create a new folder for subgrade and start to populate that, it's going to make more sense why I took the extra step to organize my surfaces into subfolders. Because my first surface that I'm going to create is going to be for my parking. And I can leave that to a set style. You'll see once we get to a certain point, it's going to make sense for us to turn some of these surfaces off or to a no display value. Again, just waiting on Civil 3D, running unusually slow today. All right, so we've got a parking surface. I'm going to create a drive surface. Let it build that. Again, these are just empty containers at this point. There's no definition to it whatsoever, but I'm naming them accordingly to the type of subgrade material that's going to be applied to them. Let's 3D catch up really quick. And then sod, or it may just be your open space grading area. Sod may not be the most appropriate name, given that it's also going to cover the pond area as well. But you pick your poison on what your naming is going to reflect. I just ask that whenever you name things in Civil 3D, it does reflect the type of objects that you intend to represent with those types of surfaces in the software. All right, one little trick about this, you can't just drag and drop a surface into a folder once it's created. You have to select it. Then once it's highlighted, now you can drag and drop it into a subfolder to begin to organize those. So I'm going to drag and drop each one of these into my subgrade folder, expand it. You can see that those 3 empty surfaces are now there. What I'm going to do is, in the definition for each of these, I'm going to paste my finished grade surface into those. And I'll go ahead and do it for all of them right off the bat. I'm just going to right click and paste my finished grade into each of those surfaces. Now, mind you, these are all duplicates. So I'm really just now getting 3 additional 4 total duplicates of my finished grade that match my finished grade surface perfectly. There's 0 difference between them at this point thus far. But I may also take this the next step and start to raise and lower my surfaces based on the subgrade depth of each of those. So if I go to sod, and I know that I need, between soil stripping and everything else, maybe I need to cut down 6 inches of depth from my proposed to account for my finished material elevation. So I can write, even without selecting this surface in the drawing. I know that's our tendency in many cases, is to select the surface in the drawing, pull up the contextual ribbon. I love the contextual ribbon too. Trust me, I use it all the time. But whenever you are at this stage in this workflow, you have a lot of duplicate surfaces right over the top of each other. And depending on the order in which they're drawn, we just want to make sure that we're picking the correct one. And sometimes it's just easier to do these edits from the tool space of the Prospector tab. So I'll right click edits, and I can raise, lower my surface for my sod. And I'm going to be prompted at the command line, how much elevation do you want to add across this surface? Well, I don't want to add it, I want to remove it. I want to lower my surface by 6 inches, or in this case, negative 0.5 feet. So now we start to see a little bit of variation in our contours. Mind you, this is across the entire site, our entire proposed site thus far. It is a perfect duplicate. But if we're ever curious as to how high or low our surface is, if our design ever changed for this project, and our subgrade depth for our sod areas or our open graded areas that don't have an engineered drive or parking lot surface over the top of it, we can always come back to our edits and re-edit this to a different depth. But the benefit of this is, if our proposed finished grade surface ever raises or lowers as part of our design, this duplicate surface will follow that. It will update automatically as we rebuild our surfaces to match whatever that new elevation is of our finished grade, but minus the 6 inches, minus the 0.5 feet that we defined within our raise lower parameter. Okay, I'm going to do that again, but for parking and for the drive. So under edits, I'm going to right click, raise lower surface. I'm going to lower my parking lot by -1 foot. Again, it's represented within my list of edits. And within the drive, accounting for the heavier traffic and the trucks and things of that nature, I'll right click and raise lower my surface to -1.5 feet for my paved material and sub-base treatment there. Now I have one finished grade surface that accurately reflects my finished grade surface. And I have 3 duplicate surfaces that are controlled by the depth of their subgrade for those material types. The problem is they're all over the top of each other still. We still have an exact duplicate over the area in which they're covered. So what I need to do is I need to come in and create boundaries for these areas. This is the one part that's slightly manual. We've got a surface definition that's perfectly reflecting our finished grade, but at the depth that we've defined. And if our finished grade design changes, these subgrade surfaces will change and update with them as well. However, the boundaries are going to be represented by static polylines that do not automatically update with our grading group. So if our grading group and our design changes horizontally in the space that it takes up on our project, then we'll need to update these polylines to match whatever our new project limits are, or that particular grading criteria's limits are. So I will, for my drive, add my drive limits boundary as a non-destructive break line. I do have some curvature to that polyline, so I'm going to lower my mid-ordinate distance. This isn't a long sweeping roadway. This is a tight parking lot design. Some of these mid-ordinate distances need to be pretty tight to reflect the curvature, the tight radiuses that are represented within a parking lot. So I may go down to even as low as 0.01 feet for my mid-ordinate distance so that we will never have a perfect curve within a triangulated irregular surface. But we can better reflect a curve by shrinking down the triangle size. And that's what we're doing with the mid-ordinate distance. We're decreasing the offset between the chord of the triangle edge and the curvature of the arc that the surface is being built off of or defined off of from this boundary. And I will zoom in a little bit, select those limits of my drive that was applied. I'm going to come in and do the same thing for my parking. I'm going to create a boundary for that. Again, decrease my mid-ordinate distance. That's going to be represented by my red line. Ooh, that was not it. Let me double check before I add that back in that I am, and I may have been picking inadvertently the surface limits rather than, yeah, that was the feature line rather than the polyline. Double check. There it is. So it was actually my magenta line that represented my parking limits. And decreasing my mid-ordinate distance to account for the curvature. You also notice that there is a slight offset between my sod limits and my subgrade limits for my parking lot. Same thing for my drive versus the sod. And that's because one of the workflow aspects that we're going to address within this is compositing these surfaces together. We're going to create 3 different subgrade surfaces, but we also need to define not just those subgrade surface limits, but composite those together into one overall machine gradable, GPS guided machine gradable surface that is uniformly defined. And in order to paste those surfaces together, they can't be perfectly stacked one on top of each other. Why? Because Civil 3D has a mathematical limitation on creating perfectly vertical triangles as part of the surface definition. Because we can't have that perfectly vertical wall or that perfectly vertical face of a triangulated irregular network, a 1/10 or a few 1/100th offset between your geometry is necessary when working with grading groups or when working with pasted surfaces. But we've got our parking limits defined now. Let me take the one additional step of our sod, and I will create the boundaries for that. And just selecting our green boundary line there. And I believe we actually have 2 boundaries for that surface. Let me make sure that we are defining that properly. First and foremost, we do have several surfaces on here. So I am going to start playing around a little bit with the styles that I have displayed. I'm going to set my proposed finished grade to a no display. my parking to a no display and my drive to a no display. And you'll notice that I have my properties palette docked over to the right on my single screen setup. Again, very much so a fan of using the properties palette and the tools that we have available to ourselves there. But there's our proposed grade line. All right, and let me also add in my other boundary. I may have to actually approach this slightly different to where I rename, because we have two outer boundaries and I don't want to create a separate hide boundary. I'm going to call this sod around parking. And I'm actually going to create one more surface. I could do a more complex boundary definition for this creation, but I also want to represent, I'm making these decisions on the fly, just like you would as part of a project. Some of this is pre-planned, some of this is pre-baked, so to speak. But I want to provide a realistic expectation of the kinds of decisions that we make when developing our projects. So again, I'm going to paste in my finished grade. I click and lower my surface, that negative 0.5 feet. I'm going to move that entire surface into my subgrade folder. And I'm going to create that new boundary around the building and the pond area. Okay, so now we have a series of surfaces around the sod, around the building, around the parking. The parking itself, I'm going to set back to a design style, and the drive to a design style. And as they're all part of the same surface style, we make sure that we aren't extending beyond. We are, so give me just a brief second. It looks like our one surface is extending beyond our boundary that I was expecting. In case that boundary is not as well defined as I thought it would be. And if I spend too much time spinning my wheels on this, I will divert for the sake of the topics to be covered today. I will divert to just moving forward with that exception, not to ignore it, but to respect everybody's time. But I will do a quick confirmation of what may be going on with that surface definition. Building definition. Edit. Ignoring the boundary, likely because there's a bust somewhere in my polyline. It must not quite be. Now it says that it's closed. So again, I don't want to spin my wheels too much on something that I may have messed up geometrically within the drawing. And I don't want to hide this, or again, Food Network magic only goes so far whenever we're trying to fit this within an hour. But I may just, for the sake of everybody's time and for the sake of moving forward, I'm just going to delete that surface. It would be much more dramatic to show that that proposed subgrade depth for the sod around the pond and whatnot as well. But we've got the design surfaces for parking. Let me double check and make sure that that boundary is set. The boundary for the drive, select that. That's the one that I'm not seeing that I would expect to see. And because I'm not seeing it, I'm going to select it and try to see it in object viewer if it might just be a flat surface. No, it's not. Again, I thought I did a darn good job of setting up my data set beforehand. It is closed, it is enabled. I'm going to recreate my boundary. Not a good boundary. We do not get, there we go. We do not get to actually use the tools the way that we want to. So we've got a subgrade depth for our parking, subgrade depth for our drive, subgrade depth at least for the outer sod. And I'll switch to object viewer and we see our proposed surface there. Obviously, it'd be a little bit more dramatic with that pond, but this is our intent, right? This is not just the design, this is the depth of the design based on our prescribed values. And we can see that distance or that offset between those surfaces, especially around the sod, where our pavement depths and our material depths are lower, where we've defined those limits to be at. And that's what we need. That's our intention, is to have those depths define our materials. Now, what I need to do is take those values and composite them into one whole surface. So I'm actually going to come up to my composites folder, and I'm going to create a new surface that's ultimately going to go into that folder that I'm going to call Composite Subgrade. And my composite subgrade surface is really just going to be a pasted surface of those other three, what would have been 4 subgrade depths. Once we have that, now we can do a full-blown comparison between our existing and our proposed, or we could take our individual subgrade depths and compare them against our proposed finish grade for our material values. Well, there's our composite subgrade, drag it into my composite subfolder, and then I will create a pasted surface made up of our parking, sod, and drive surfaces. And if I were to select that and view in object viewer, we'll see that those gaps between the material volumes are still there, but it's all part of one surface. And the key point in this is that in being all one surface, we're able to create a volume surface for our overall earthwork calculation. How do we create volume surfaces? Well, there's a number of ways to do it. We could certainly do it from creating the surface, creating a volume surface. From there, I like to use the volume analysis dashboard that we will see on the Analyze tab. And bear with me again, I think it's just getting out of the surface creation dialog that for whatever reason is acting a little bit slow today. There we go. Analyze volumes dashboard. My panorama is sneaking over here to the bottom left. I will create a volume surface comparison. Again, what type of surface? Create a surface, a tin volume surface. I use the dashboard just as a method of going through this process and showing people where we're going to get the output. But really the process is the same as if we were to create this surface from the surfaces dialog. That's essentially what we're looking at here. I'm going to call this my earthwork volume surface. I guess I could leave the word surface off of there. For the style, I'm going to leave it at the 1 in 5 proposed, but ultimately we're going to use an analysis style. And I may even just create one as part of our webinar today to show you quickly how to create an analysis within our surface itself. Because we don't currently have one in this drawing, at least not for elevation banding that I want to show. We've got some flow, arrow, and some sloping analysis, but I want to compare our depths. So our base surface, unless it's a phased project and what used to be proposed is currently existing, you're going to use your existing site surface, your survey data, as your base surface for comparison. And then our composite subgrade surface. Now, if you have loose loamy soil or you have compacted clay soil and you're accounting for cut and fill factors, maybe it's 1.2, maybe it's 1.3, regardless of the type of geography you're in and the soil's conditions, we can account for those cut or fill factors within this calculation. Once we create the surface, we're still not held to it. We can adjust our cut and fill factors after the fact as well. But we see actually a fairly small amount of fill compared to our existing, mostly a lot of cut on this site. And we can see a little bit more graphical input with this flyout tab for our overall site cut and fill balance. And if I change my surface style, again, creating a new style for analysis, you can see right now we do not have an analysis style for elevation banding, and that's what we're ultimately going to create here. I'm going to take the 1 and 5 that we're currently on, and I'm going to create a copy of that current selection. I'm basically going to ignore the settings of that 1 and 5. I'm going to change the name of it to elevation banding or elevation analysis, however you want to define that specifically. And there's really only 2 tabs that I need to concern myself with when working with a volume surface and an elevation comparison. It's the analysis tab and the display tab. I don't need to see the major or minor contours. I can choose to, certainly, but I'm not concerning myself with it right now. I want to see the elevation analysis. And from the analysis tab on the elevations collection or node, once I expand it, I can define the basic parameters. These are the default parameters of an analysis that Civil 3D will automatically produce without any further input from ourselves. So the number of ranges, the type of color scheme, rainbow, if you will, reds or blues or pastels. If you're doing a terrain type surface, we have a really great land analysis that is kind of reflective of our old topography maps. But we're going to use number of ranges, quantile 8, range precision 0.01. This will allow us to produce across the spectrum of elevations that we have between our comparison surface, a series of color scheme that's going to be automatically produced. But I'll apply that. We can see the earthwork analysis in effect. Again, this is not our depths of our subgrade compared to our proposed finished grade surface. These are the depths of our existing surface compared to our subgrade depths. And the more red the color, the more intense our amount of cut is for that earthwork and site preparation that a contractor would have to go through. But on the analysis tab of the surface properties themselves, we can actually go through and override that analysis type. We can say, yes, from the dropdown, we want to perform an elevation analysis. I don't care about a table right now, but I can change the number of ranges that I want to be provided, or I can set what I want that range interval to be, or what the datum elevation of that range interval is. So if I want to see whatever elevations are above or below 815 feet in elevation, I'm going to get a series of reds and greens and other color variations that are in cut or fill above that datum. Otherwise, it's going to be the comparison surface. I like the number of ranges. We hit the apply arrow to run that analysis, and then we can redefine what those ranges are. If we want to say, well, a minimum elevation versus maximum, if we want to, oh, and I actually am looking at the wrong surface while I'm making these changes. So bear with me for a second. I'm going to switch that back to the 1 and 5 proposed for, actually, I'm going to switch that to no display since it's a subgrade surface that we wouldn't see on a set of plans. And I'm going to flip back over to my volume surface. I chose the wrong one when going through this process. I'll go to surface properties there, switch that to the elevation banding style that we created previously, and I'll produce my number of ranges. Those are the kinds of elevations that I would expect to see in a volume surface. Again, it's not the overall elevation as we would think of it compared to our benchmark or our datum. It's the elevation comparing the amount of cut and fill between the projects. So we have just a very de minimis amount of fill in this project area. And that might be something that I structure as green. Again, the color scheme is based off of the style that we utilized within the elevation banding style that we just created. But I can go through and I can edit this to maybe even a more intense or darker red for the amount of cut that we're in. If I needed to change the ranges a little bit to just kind of highlight some things, or kind of restructure it on, instead of a quantile range, if I needed to change it to maybe every half a foot or a quarter of a foot range, I can certainly do that. So if we're getting a little bit closer to an even cut, maybe I structure this just a little bit higher, and then more or less even. And again, I can edit any of these elevations, but for the sake of time, I'll leave that alone. We can see the comparison of that surface. I can also structure this to where it's semi-transparent. And if you check out Kyle's webinar from last week, you can see that it's actually fairly straightforward to not just stylize this surface with the elevation banding and to tell where that cut and fill is going to happen. But we can also add spot elevations on a grid from one end of the project to the other. And we can define numeric values on a 10 by 10 or 20 by 20 grid of spot elevations, and even use some different elements of our labeling styles, and not just the labeling style itself, but some expressions within the label styles to define those as red or green, depending on if it's in cut or fill, and the amount of magnitude or intensity of cut and fill that we have. So again, shout out to Kyle on that, but we're not quite done with this. Yeah, this is great. If I needed to adjust my design, I could adjust my finish grade up or down to find some earthwork balance here. Obviously, I would still need to tie into existing, but if it was an open greenfield development, I could do a blanket raise or lower of my design surface, and my subgrade surfaces would follow. Given that I'm tying into existing on this design, I could adjust a couple of my feature line elevations, which would subsequently change my feature or my finished surface grade, and then subsequently update my subgrade depths as well. So whatever the case may be, in our method for updating that surface and finding that balanced earthwork calculation, it's all dynamic at this point. We make one change to a feature line, it updates the finished grade updates all the subgrade depths update the composite grade, and then our volumes dashboard updates as well. The only holdback, if you want to even call it that, is whether or not you set your surfaces to rebuild or rebuild automatic. I'm a big fan of manually rebuilding so that every little change that you make does not pause Civil 3D and force you to wait 10 seconds, 30 seconds, however long it's going to be. I did receive a question while that happened. So I'm going to address that really quick while I kind of recenter my chi and move forward with the workflow. But this comes from Jason. Jason asked, I need to move on to my workday, could you provide an email to all of us first timers using Civil 3D for earthwork? Would you have an email with step-by-step screenshots showing the process for earthwork creation? Jason, I would like to say yes. Ultimately, I'd have to point you to more specific training for learning how to build up those surfaces. What I'm starting with here, the grading groups, the framework of feature lines and things of that nature. So if you're still with us today, thanks. If you're going to watch this response to you as part of the recording on YouTube, telling you how to create a grading group, how to use some of these other tools, their fundamentals. I don't mean to diminish their value. We absolutely need to know those things. And it may be part of a future topic of one of our ATG webinars. But there are certainly resources out there. We are certainly more than capable at ATG of providing training on those particular topics. And it's something that I love to train on because there are some really unique workflows for site grading and the use of grading groups And for that matter, one of the tools we'll be talking about today, the Sim Project Suite, as we finish up these last few minutes. So with that said, because I had a hard crash of my entire system, I'm probably going to be prompted whenever I jump into this tool for the third-party update or workflow for this. I'm probably going to be prompted for a license. No, I wasn't. Okay, good. So we have Earthwork Processor in the Sim Project Suite. So everything that we've done up to this point, yes, some of it took a little bit of time to set up. The polyline boundaries that represented our grading depth areas, our pasted surfaces and lowered subgrade depths of those surfaces, and then composite together. But we weren't really creating new data. We weren't really increasing dramatically the size of our file. We're using the finished grade surface and just some duplicate modified versions of that surface to represent our subgrade depths and our composite subgrade. So with that said, we weren't dramatically increasing the file size. The one thing that did was that comparison volume surface. That's one thing certainly that would increase the file size of our Civil 3D drawing. So hopefully you like that workflow. It's something that works for you. If you wanted to look for something that's slightly more automated, although not quite as intuitive, it's faster but less intuitive. Go check out Kyle Grove's webinar from last week, Thursday, that's on our YouTube channel right now. But I'm also going to cover, again, out of respect for everybody's time, in an abbreviated fashion. I'm going to use the Earthwork Processor, and again, ask you to bear with me as we run through this fairly quickly. Really quick, got another question. As someone who's done subgrade quantities and hand calcs, what are the advantages of doing it inside of Civil 3D? The benefits of doing it in Civil 3D is that everything updates automatically. You have a surface that updates, you have a design that updates. Well, guess what? You've got a volume that updates automatically as well. So rather than having to re-hand calculate, update your Excel spreadsheet to make those changes, you've got a dynamic improvement. So yeah, it takes maybe 15, 20 minutes to set this up. But once you have it set up, it carries through for the remainder of the project. Any changes will be reflected in those subgrade depths and your earthwork quantities and your material quantities and things of that nature, rather than having to recreate the wheel with every design change. And Jordan asked, how big of a gap does one need to have between the two lines when creating a composite surface? In general, whether it be a grading group, whether it be manual feature lines, Civil 3D requires at least a 0.01, a 1/100th gap in your vertical surfaces. So it's de minimis. It's not going to affect your earthwork quantities to any significant value that's going to change what you present to your client. So 1/100th of an offset is all you really need. I tend to make mine a little bit closer to 25 thousandths. So just a little bit larger than that. And the reason being is the curvature. I'll jump back into this tool because this is a really important question. As we have that curvature around a parking lot or a roadway for that matter, or parking islands, and we have those mid-ordinate distances, those chords of our triangulated surface that cuts across these arcs of our surface definition, we need to make sure that those don't overlap. That's the big thing for me. So I end up typically, I know I used a 1/100th when defining my boundaries earlier. But in general, whenever I have these type of curves, yes, 1/100th is going to get me the most accurate representation of a surface, but I want to use at least, or at largest, a 0.025 distance. Anything larger than that, you're probably going to chance your chord distances or your chords cutting across this arc intersecting with each other, and then you're going to run into some issues about where those vertical surfaces are. So I like to keep those the line work offset by at least 0.025, but my mid-ordinate distances as small as possible to avoid those overlaps. All right, jumping in really quick. And again, Kyle covered this pretty extensively last week, again, using a different out-of-the-box workflow, but finishing up with Earthwork Processor as an alternative. I'm going to create a new set of grading, and I'm going to call this my sod. Again, I'm going to use my information that we had available in this drawing the same way before. I'm going to filter by layer. If I don't know what my layer name is, I can just select it, the item that's on that layer in the drawing, and I can define, what's my subgrade depth compared to my, not compared to my finished grade, but rather, yeah, compared to my existing grade. Oh, no. There we go. Finished grade. I flipped those around now that I'm flustered because of that reboot. But I need to define what my cut and fill factors are, what that subgrade depth is if it's a static value. So what's my cut? It's 0.5 because I've got two bounded areas. I've got two objects here. If I did need to do some preliminary stripping and earthwork stabilization, what's that depth? Maybe that's just an inch, maybe that's a couple inches. 0.1667, 0.1667. And that's going to define some surfaces for my subgrade around my sodded areas. I can add yet another criteria. This is going to be my parking. My parking is going to be, again, my comparison of my finished grade compared to my existing grade. But again, it's bounded by that parking layer. And again, that was my magenta line there that represented that depth. And because there's only, I believe, one bounded area, let me scroll, there we go. And that was 1 foot. It was 1 foot, and the stripping, again, of topsoil. And yet one more criteria for our drive. And I'm trying to run through this fairly quickly, not to cheat anybody out, but to respect the time and the unfortunate snafu of the entire workstation crashing on me during the middle of a webinar. Still stripping. And I'm going to run all of those. If I missed a step, if I missed a setting, again, I apologize. I know we're right at time, and I want to allow for just a little bit more questions. If you have them, please feed those my way, and I'll continue to answer them if you've got them. Thanks again for sticking around with me. And it's going to just take a moment to not just process these differences, but actually create those surfaces at the same time. So it's Civil 3D using the Earthwork Processor from the Sim Project Suite is doing everything that we did before in 20, 25 minutes. Again, all the pre-configuration of the pasted surfaces, the lowering of those surfaces, the compositing of those surfaces and things of that nature. And it's converting those now, that manual process from out of the box using Earthwork Processor. It's doing all of that in the background. There we go. I forgot to hit yes. Again, being flustered. My apologies. And it has not just created those surfaces, but if I go, you can see, again, my folder structure was the same before as what this one started out as. I created an empty composites that the Earthwork Processor did not use, but it actually created some new volume comparison surfaces automatically for parking, including the depth, the stripping, and the subgrade. For the sod area, the depth, the earthwork, the stripping, the volumes. And if I go to my Analyze tab, we can see where if I brought those surfaces in and evaluated those volume surfaces, the stripping, what's the earthwork values of those, the subgrade for my drive, what's the value of that. So I'm just adding the surfaces for parking. Let me get rid of that one. So the subgrade volumes for my parking, for my drive, and for my sod area. and the overall balance of cut and fill on a project between those three areas. So one thing that it didn't do that we did earlier was create a composite of those three different subgrade areas, but it automatically bounded, it automatically created, and it automatically lowered those surfaces to the values that we defined. And rather than having to go through and manually edit those values, going into a surface, going into a definition and modifying the edits portion of that surface, we can manage that entire process directly from the Earthwork Processor tool inside the Sim Project Suite. And we have one overarching area that we can manage all of our subgrade depths. And then just rerun any changes that were applied. We can add labels automatically. We can apply some shading, again, based on those depths and the intensity of cut based on those depths. But again, I encourage you, for the sake of time of this webinar and respecting your need to go back to work, I encourage you to check out Kyle's webinar from last week, where he goes into just a little bit further depth, some of the edits that we can make to this, the changes that automatically apply to those surfaces as part of this Earthwork Processor tool. And I also encourage you to check out the 15-day free trial of the Sim Project Suite. And if you do use that 15-day free trial, to not worry about losing any data that you worked on. There is nothing proprietary about these tools. Yes, the tools themselves are proprietary and part of a licensing, but all of the surfaces that were created, all of the data that was created in the Civil 3D drawing is out-of-the-box stuff. Yes, it was created and generated and can be updated through the Earthwork Processor, but it's not beholden to that. It doesn't lock you in. It's not like these surfaces become unusable or untenable after a 15-day trial. So try it out. Find out just how much value there is to these Sim Project Suite tools in your office without fear of pigeonholing yourself on a project, or if you're just testing it out on data and the 15-day trial ends, most of us probably wouldn't test it out on a live active project, but that data is still viable. It's still the out-of-the-box data. It was just created and can be managed from the Earthwork Processor after the fact. That said, I see our participants list is slowly starting to dwindle. I would ask that anybody that has any remaining questions, go ahead and ask those now. I am, in the meantime, going to pull something up, and I see, nope, that one's been answered. I believe I addressed that one as well. Give it another minute or two for anybody else who has questions. And other than that, I will, again, I'm kind of flip-flopping through this a little bit because of that unforced shutdown. But we went through our subgrade surfaces information in Civil 3D, the out-of-the-box tools. We created a volume surface, and we demonstrated exactly how to do that with the out-of-the-box tools. The better way, in my opinion, is through those earthwork processing tools from the Sim Project Suite. It's faster, it's more automated, and we have a little bit more granular control over it after the fact, rather than manually editing and updating and all of our subgrade depths through the surface edits. So we demonstrated that. I encourage you again to reach out, stay connected with us on LinkedIn. Feel free to follow me directly on LinkedIn. I share as much as I possibly can with upcoming events and free content that we publish across our civil team here at ATG, which includes our Bluebeam, our Civil 3D, our InfraWorks, and all the other great tools that we work with, train on, and consult with here at ATG. But whether you're a civil specific firm or you're a multidisciplinary firm, follow us on YouTube. We have at least weekly, oftentimes multiple times a week, free webinars. On our website, we have blog posts regularly for just tech tips and helps and workflows that would improve your daily life on projects, as well as really in-depth white papers that are industry related and workflow related. So thank you for your time. Thank you for hanging in with me during that quick pause while I rebooted. And again, feel free to follow me at any point in time. There's my email address. Reach out. I'm on LinkedIn, like I mentioned before, and we love providing these resources to you, and hope you've seen the value in taking advantage of these tools. And if not your daily workflow, at least on the occasional project where you run into the calculations for subgrade depths when you're on area and site projects rather than a linear corridor project. Thanks again. Thanks, Bill, for your comment. Thanks, everybody, for attending, and we look forward to the next time we see you on an ATG webinar. Take care.